1F inverse functions. Here we go. So, inverse functions. Inverse function is a function in which you undo or you reverse its operation. So, if you think about this square root graph, square root is the inverse of a quadratic which is squaring. Which is why, when you think about the graph, they're very similar. They're very similar. You've got a parabolic shape moving towards the y. If you're looking about your square root relation, not function, it's actually a parabolic shape towards the x. Okay, it looks very, very similar. And the idea comes from the idea we're saying that in order to reverse it, it's actually the reflection, or the inverse is the reflection in your in the y equals x axis. Okay, so y equals x line. That's what it actually is. And so, when you do that, there are a couple of properties that you need to know. Let's go back to a bit of a revision on functions again. There were 4 types of relations. What were the 4 types of relations again? Can I please have, let's go with Cindy. 4 types of relations. Are you Cindy? Oh, there's 2 Cindys, aren't there? I don't know your surnames. Let's go Cindy. Cindy Gale. Cindy G. 4 types of relations. What were the 4 types again? I'll give you the first one. We have a one-to-one, one-to-many, many-to-one, good, many-to-many. Now, one of the important things, which is why it's all examinable, I'll tell you why here. There are 4 types, but there's only going to be one that works, that works for inverse functions. Now remember, what did I just say before? I said inverse functions is when you reflect along the y equals x line, which just basically means y is equivalent to x. If y equals to x, technically now y is changed to x and x has changed to y. So now you've technically swapped them. That's why in your technique from last year, they said if you want to find the inverse function, swap the x and y's. I said, oh, you didn't do it. Okay, well, some classes did it. But if you didn't do it, that's good, we're going to do it now. Okay, so maybe I'll just write that note down then. When you're doing this, basically is a reflection in the y equals x line. What does that mean? So remember the mirrored images. When we say reflect on the x-axis, you flip it on the x-axis. When we say reflect in the y-axis, you flip it across the y-axis, right? Well, now you're going to flip it not on the x-axis, not on the y-axis, but you're going to flip it on y equals x. And I'll show you a quick example why the pictures look they do. Here we go. This is a quadratic graph. Like that. Okay, I know it's terribly drawn, but I'm doing it on digitally, right? You got a quadratic graph. Now, a y equals x line looks like this. I'm going to do it in green. True? That's my y equals x line. What you notice is technically there's a bit of a cut between here, but that right there, if I did a reflection, if I took whatever's on this side and I flip it over, see this line that curves towards that second quadrant is now going to curve towards the bottom quadrant. Okay, 4th quadrant. So if I draw out the reflection, this is what you're going to get. I'm going to do a blue line. The reflection is going to be like this. If you think about this, just from this dot, from that green line where the intersection is, it's going that direction. It's curving up in that 1st quadrant. Then it will be curving this way in the 1st quadrant as well. So instead of going up towards y, then it's now going towards x. So if I follow that line, see, watch, this goes like this. I'm just trying to mirror the image here. Okay, I'm trying to mirror the image. And then in between it, there's a little bit of like a curve underneath the green line. Then now there's going to be a little bit of a curve above the green line. So I'm just going to draw that just a bit above. Now can you see the red line is a quadratic, that's x squared. If I drew this properly, technically this is a square root relation. That's what you're used to. You've drawn a square root graph, that's a square root function. This is the negative square root function. Okay? put them together, this is the inverse. The square root is the inverse of squared. And you can do that for every graph. Exponentials, if you remember, if you did the same thing, so if I drew an exponential now, this is what exponential graphs look like. True? And then I draw a green line, like a reflection, then you would say that the reflection would look like this. True? Just mirrored images. Now remember last year, if this is exponential, what was the inverse of exponential? Log. That's a log graph, which is what you learned. You said asymptote right on the x equals 0, and it curves up. It's the same thing. This is an asymptote on y equals 0. What happened? Reflection on y equals 0, x. Because x now, the asymptote on y equals 0 now becomes x equals 0. Everything switches. This is why your log graph looks like that. So all your inverse functions follow one property. What was that first property? A reflection in y equals x. And one of the techniques to find the equation is you swap the x and y's. Technically, you're just doing a substitution. Okay, so in case you didn't understand what I just said, a substitution just means if you had y equals x squared, and you know this is the property for the reflection, then now for all the y coordinates, they are now the x, and all the x coordinates are now the y. So all I'm doing is I'm saying this y is now equal to x, and this x is equal to y squared. So if you want to sketch the inverse function, we always sketch it with the y being the subject, meaning make y by itself. That's what subject means. So if I do that, to get rid of the square here, I square root both sides, and now you get root of x is equal to y, and this is called your inverse function or relation. In our case, it's going to be a relation, okay? But if it's a function, then it's just positive. If it's a relation, it would have been plus and a minus. Yeah.
Why wouldn't that just be
1/2. Yep. X to the power of half.
like the y?
Good. Yes. The y equals square root x would only be this top half, which makes it a function. But technically, when you square root an answer, there's always a plus and a minus answer. True? Like square root of 9 is positive 3 and negative 3. So you should have the positive and negative, but then it's not called a function anymore. It's called a relation. So you would say this is meant to be a square root relation, but if you call it a square root function, then it's only the positive one. Yes, Alfie? Sorry? Can it only be negative? What do you mean? Yes. Yeah, it can only be negative as well. So you can have a square root function that is just negative and it's only the bottom half. So it's like that. So you can only have that part. But technically, from this step to this step, it's technically a relation unless there's a definition that said it's a function. Then you would only take the top half or the bottom half. Yeah? All right. So today, what I just went through with you was the first property. Reflection in y equals x means that the x is equal to the y and the y equals x, and that's why it feels like you've just swapped the x and y's, but you haven't. You've done a substitution. You said that all the y is equal to x, and you said x equals the y, and you made y the subject to find out what is the equation. So that's your new equation. We call that the inverse function or inverse relation. Now, this leads on to the second property, which is what they test in your multiple choice. We said there are 4 types of relations. You have one-to-one, many-to-one, one-to-many, many-to-many. What was happening in the reflection was you said the x becomes the y and the y becomes the x. So essentially, a one-to-one function will switch to become a one-to-one. If you had a one-to-many relation, which is not a function, then it now becomes a many-to-one, right? Now, the interesting thing is, out of the 4, there's only one that you start off with a function and you end up with a function. Which one is that? It has to be one-to-one. That's the only one that if you swap the x and y's, it's still a function. So that's why when they ask you to find the inverse function, there's only one way that you can only have an inverse function. That's why I said it's important to understand what a function means, because some of the questions you're going to get, sometimes they'll ask you to find inverse relation. And that way you have to know that, okay, if it's a relation, I can have a plus and a minus. If they said it was an inverse function, then you had to make sure, is it a one-to-one? Because one-to-one was the only one that if you swap the x and y's, it's still a function. You see, the many-to-one is a function. If you swap it around, it now becomes a one to many. So 1x to many y's is not a function. So if you forgot the machine, I'll draw the machine again. 1x, so 1x to many y's is not a function, because remember the definition of a function is whatever you put in has to only have one result out. Hence why any one of those where on the back says 1, that's the correct one. That's the one with a function. So that's a function, that's a function. But though this is a function, a many to one function, which is this quadratic. Quadratic's a many to one. 2x's or the 1y. If you did the reverse or the inverse, it actually ends up being an inverse relation. That's why a many to one doesn't have an inverse function. Okay? And that's one of the things that they're going to do to you. They're going to give you cubic graphs. They're going to restrict the domain. It looks a bit weird and whatnot. But your job is to figure out where could I have a one-to-one. So I draw a cubic graph for you to see. We draw a cubic. How can I make something a one-to-one function? So let's here we go. We've got a cubic graph. If you try to find the inverse of this, it's not going to be a function. Part of it is going to be a relation. So your job in this exercise and your exams at the end of the year, what they're trying to test you to see if you understand is the first two properties. It's a reflection in the y equals x, but then that also means it needs to be a one-to-one to have an inverse function. Okay, you need a function. So in this graph here, that's not a one-to-one. That's a many-to-one right now. Okay, is it a function? Do a vertical line test. It is a function. Do a horizontal line test, then it ends up being a many-to-one. So now that you know it's a many-to-one, your job is to look at it and say, well, where can I have or where can I restrict the domain so that it becomes a one-to-one? Now, which parts, there should be 3 parts in total that you can have a one-to-one if you restrict the domain. Where would it be? Yes, the turning points are the key, because all these points are individual points up until the maximum. So you think about, these are the points I'm going to do in red. You have 3 parts. You either work between, and I'm going to highlight them, from here to here, that's going to be a one-to-one. If you found the maximum minimum, now we'll think about last year, what technique have you learnt last year that allows you to find maximum minimums? Derivatives, which is the next chapter that we're going to do after functions. See, chapter 9, the reason why we do it is because it links in to allow you to find the maximum minimums. Find the derivative, stationary points tells you the maximum minimums. Now from here, you could say the domain is from this x value, which I'll do it in red. You can say it's from this x value, x1 to x2. That would have a one-to-one. Where else can I restrict? So that's the first area. I said there were 3 areas in total. What are the other areas that you could restrict this graph so that you can have a one-to-one? Good. x2 to infinity, if I did it in blue, highlighting in blue here, it could, but for a cubic graph, it technically just goes up. But you're right, sometimes we don't know, and then therefore you have to test it or you have to look at the overall function. Yeah, see, sine graph or cos graph, you'd have to restrict it only from the top to the bottom, maximum minimum. That's good. Okay. Same thing you've also got from x1 all the way to negative infinity. That's your third region. But here we go. So why? So whilst I'm saying all this and it sounds and it makes sense, why is it hard in your exam for a multiple choice? Where do students go wrong? It sounds pretty simple right now. I'll tell you where. The reason why most students get this wrong, and I'll show you 2 examples. With this example, it doesn't have to start at the maximum or minimum to have a one-to-one. I could have said, instead of x2, I could have still done at this point and downwards. That's still a one-to-one. And in your multiple choice sections, there's going to be a random number that indicates it's this. And then the rest is the maximum minimums. And most students look at the maximum minimums. They're looking for these. And then they're like, oh, I don't know, maybe it's this one. And then it might just be out. It might be from here to over there. And you're meant to know that as soon as it passes that minimum, it can't be a one-to-one. It becomes a many-to-one. That's where they're going to try to get you. And I promise you, if you look even your checkpoints, if you have it now, go to your function section, find the question with the inverse function. There's going to be one like that. There's always one like that. What's the second one? So that's one scenario. I'll show you another one. Another typical one, and I talk about visualizing your problem. I'll show you here. They will give you an inverse function or a function, and then they tell you to state the range of the inverse function. So they'll tell you the inverse function is, I don't know, let's say y equals to 6 minus x between a, open bracket, b. And they say find the range. Now you see, if you don't try to picture what this graph looks like, you're going to answer straight away what it looks like. What do most students do to find a range? See, I gave you a domain A and B. One's inclusive, one's not inclusive. What's the first step you think you're likely to do? What are you going to do to find the range? How do you find the range? One other graph, but most people don't do that. What do? You sub it in. That's the first sort of logical thing. If I put 0, 1, your first step is always going to be sub 0, sub 1 in. So if you sub it in, you sub A and B in, this is what you're going to get. You're going to get, when x equals a, you'll say y equals to 6 minus a, but you don't know what 6 minus a looks like. You're just like, it's 6 minus a, and you sub in x equals b, and you say y equals to 6 minus b. And so what do you think they're going to say, or choose in the multiple choice, they're going to say, which one is your range? If you put in a first, it's likely you're thinking 6 minus a to 6 minus b, inclusive of this and non-inclusive of that, true? That's the first step that you're going to do. And the examiners know that. The examiners know your patterns, and they're going to do it the other way around. And this is where you get it wrong. And you're like, what did I go wrong? Sub it in, find the range, and it was inclusive at A, so surely it's inclusive here. Where's the range going wrong? Can someone explain to me why, if I did that, if I told you the range was between 6 minus A, so inclusive, and not inclusive at 6 minus B, where have I gone wrong? What's the mistake already? Say it again. Speak the smaller. And I'll tell you why. And you look at all the examples, I promise you, it's that negative. Say negative, it's a negative gradient. So if you think about it, negative gradient means it's top to bottom. So A would be over here. A would have a higher y value. B has a smaller y value. So when you write your range, it's from smallest to largest. So it should be 6 minus B, open bracket, to inclusive of 6 minus A. That's why I'm saying draw the picture, visualize it. Because if you drew the picture, it would have been obvious. If you drew it and I did 6 minus A, it's a y-intercept at 6, goes down, that's 6 there. We don't know where A and B is, but we know A is smaller than B. Then surely 2 points, let's say A is over here, that's A, and let's say B is over here. Clearly you can see the range is from this y value. At B, it's 6 minus B, all the way up to 6 minus A. A is inclusive, B is not. So when you write your range, it's from the bottom up. Okay? Visualize the problem, draw it, because those two examples are your most typical when it comes to inverse functions. If it's a short answer question, then you have to sketch, which is what exercise 1F is about. I haven't done sketching with you yet. I've just given you the first 2 properties. Okay? So what were the first 2 properties again? Reflection in y equals x. And number 2, because it's a reflection y equals x, that means x equals y, y equals x. Therefore, for you to have a function, it has to be a one-to-one. So write somewhere in your notes, I want you to always get this right. It needs to be a one-to-one. There's no other way for you to have a function to end up with an inverse function unless it's a one-to-one. That's what they're going to test. And you're going to learn by restricting the domain using 1b, 1a to answer the question there. Okay, so it has to be a one-to-one function to have an inverse function. Write that somewhere.
How did you know that 6 is in between A and B?
No, I don't know. I just made it up. So that's the thing. We don't know where A and B is. But we do know that A is smaller. So if A is smaller, then the y value has to be higher than B. It doesn't matter where you choose it. See, if I chose A over here and B over here, A still has a higher y value than B value. And so therefore the range is always starting from the smallest y value to the largest y value. So that's why this was wrong. Because 6 minus A is the higher value. So it should be written around, and that means the open bracket and closed brackets should be the other way around too. Okay. Here we go. Lower value on your x-axis. So let's say A and B is here, but when you draw a line down, A is always going to be the higher value. B is always going to be the smaller y value. See, this is your f of A, and this is your f of B. That's why the range would start from here to there.
Did they give you the domain as A to B?
Yeah.
Oh, and then so the range is the
And that's what I mean.
Yeah.
And kids will lose that because of A and B, they don't know where it is,
Yeah.
and they're not picturing it, and they just sub it in, and once they sub it in, they only got 6 minus A and 6 minus B. The natural reaction is just to go inclusive, non-inclusive,
Yeah.
and that's the wrong answer. And there will be an answer in the multiple choice, and so they're like, yes,
Yeah.
there it is, but it's not.
Yeah.
Yes. Are they always going to give you a domain? Not necessarily. So they could give you, if they want to swap it around, they could give you the range, and then you're going to work out the domain. But most often, these questions are the first few parts of the multiple choice, and so it's likely they'll give you the domain to find the range. If they want to spiff it up, it'll be further later on, like 15, question 15 or 12, somewhere there. All right, so let's recap. What did I tell you? It was a reflection. So point number 1, reflection in y equals x line. I said that in order to have an inverse function, it needs to be a one-to-one function. For inverse functions to exist. All right, and I said there were 3 properties in total. If you swap the x and y, not only does the graph reflect, what else changes as well? Domain and range. Your last property, these are the 3 things they'll test. Domain of your function, so if it is a function, domain of your function is now equal to the range of the inverse. Similarly, the range of your function now is equivalent to the domain of your inverse. The beauty about this is, every time they give you a function, especially if they write it as function notation, they give you the domain. So that means you should know straight off the bat the range of the inverse. And if it's in your short answer questions, it's always 1 mark. It's like right there in front of you. Just write down the answer. If they told you the domain, you already know the 1. The only thing you need now is just to find the domain. And if you want to find the domain, just sketch the domain, sketch the graph. That's what I mean. The more you can visualize your problem, the easier it is to answer these questions. You didn't have to, reflect it, swap the x and y's, find the equation, sketch the inverse equation. You didn't have to do that. Sketch the normal equation, find the domain and range from that, and then there you go. You got your domain and range for the inverse. There was nothing hard about that. But if students who struggle with that question tells me, 1, they can't visualize it. That's why visualizing is important. You need to be able to look at the question and say, I know what it looks like. Okay? So there you go. Those are the 3 properties. I'm going to go through some examples with you. To practice that, we're going to practice finding the equation. We're going to practice defining it using function notation. We're going to find domain and range. And the last part, which is the hardest part, sketching. Sketching has always been hard. It's just analyzing has always been a pain, right? You need to practice that. But that's exercise 1F. So if you wanted to know what was in 1F, those are the 3 that I want you to take down. Okay, that's what you have to master. Well, that's what you have to know. All right, here we go. Let's do some examples. Here we go. Let's find the inverse of each of the following functions, stating domain and range. Let's do A. Let's start off easy. Looking at that, what should I already get? What should I already have? The range of your inverse. That's the first thing you should write down. If you're doing anything with an inverse function, write it down. You already got the domain of the function, which is -2 to 1. Then you know that the range of your inverse straight away is the same. Okay, we don't know what the domain of the inverse is, but it's okay. Visualize the problem. Now you got f of x equals 2x plus 3. What kind of function do you have there? Linear. Is it a 1-to-1? Yes, so therefore it must have an inverse function. That's the first question you should ask. Don't jump in to the question and start doing this. Don't do this. X equals 2y plus 3, and then just start doing it. Because there'll be some functions that is clearly wrong, and you just do that, it won't work. Because the answer would have been, it doesn't exist. And you're doing all these mathematics for nothing. Okay, so the first question you should ask, is it a 1-to-1 function? If you want to find an inverse, it needs to be a 1-to-1, right? Now, once I've got that, I'm going to sketch the graph. Right now I've got f of x equals to 2x plus 3. We know it's a straight line equation, so going back to year 9 mathematics, y-intercept and x-intercept are the easiest way to sketch this graph. What's my y-intercept? 3, so I draw a 3 here. I'm like, okay, 3. And what's my x-intercept? -3 on 2. So let y equal to 0. So for those who've forgotten, let y equal to 0. Minus 3 on both sides. Divide both sides by 2. -3 on 2. So when the y coordinate 0, what is x? X is negative 3 on 2. So let's say here, negative 3 on 2, I've got my graph. But what have I done wrong already? What am I missing? This is the mistake that most students do. What have I done wrong? I haven't put in the domain. Don't just sketch without doing the domain. Domain is very important. It dictates what your final answer should be. So whilst you're drawing it, if you're unsure, look at the domain, find out the endpoints first. It just so happens negative 3 on 2 is less than, also it's greater than negative 2, so it's okay. Negative 2 would then be over here, so I can go, all right, it's inclusive. I don't know what the endpoint is. How do you find that endpoint? Yeah, because you know that negative 2 is your x value. Sub negative 2 into the equation. Negative 2, when x is negative 2, negative 4 plus 3 is negative 1. So now I know this is negative 1. So negative 2, negative 1. Whereas the other side was all the way up to 1. So I'll say 1's here. I need to know the endpoint when x is 1. 2 times 1 is 2. 2 plus 3 is 5. Voila. Now remember I talked about visualizing it to answer the domain and range. It's so much easier now. You already got the domain is negative 2 to 1. What is the range? Yeah, negative 1 to 5. So looking at this, I can say now range of f is negative 1 to 5 inclusive, and that is the domain of the inverse. The only thing I'm missing right now is to find the inverse function, because I have to answer the question that says find the inverse of each following functions and then state domain and range. I already got domain and range by visualizing. And it's important to visualize because you skip this step, sometimes you could get this one wrong. And why get something wrong for something easy? You want to get all the easy ones down and leave the hard questions last. You've got more time to take your time to read it, to think about it. So the easy questions, get it right. Do the basics so you get them right. Don't lose marks for things you know. Lose marks on things you don't know. Okay, so end of year, that's your goal. Your goal is to do all the easy questions as fast as you can, leave more time to do the harder questions. Okay? Now, let's find the inverse. So remember I said the inverse occurs when you do a reflection in y equals x. So technically it's a transformation. And what I've done here is I've said all x, y coordinates now will become, x becomes y and y becomes x. That's all I'm saying. All right? This is how I would write my solution if I were to do it in an exam. Okay, so I would write, okay, because of this, the inverse function will occur where I'd say let f of x equal to y. And here I go, I would say y equals to 2x plus 3. Therefore, now it becomes x equals to 2y plus 3. Solving for y, this now gives me x minus 3 equals to 2y. And finally, y equals to x minus 3 over 2. Don't leave your answer in the box that I just wrote there. Why? Function notation. So remember when I talked about writing your function notation, the proper way of answering this 2-mark question is to write in function notation. And notice what I did in between. Why did I say f of x equals y? What did I do that for? Why didn't I just jump straight to this line? Because most students jump right to this line straight away. Why have I gone through this to that, to this, to that? One, it's working out, but two, the letter y is a made-up variable. If you just answered your question and left at that, the examiners will not give you a mark because you started off with an f of x and suddenly the y comes out of nowhere. They're like, they might know what you mean, they know what you mean, but they're not going to assume that. As part of being an examiner, they're going to assume that you don't know anything until you prove otherwise. So, if you write y out of nowhere, they need to know where this letter y comes from. If it started off with a y, fair call. But if it didn't start off with a y, it is good to state that the f of x, I'm treating it as a y just so I can solve for the inverse. But that means your final answer can't be left with a y. We're going to have to write it as function notation but with the inverse. So here we go. This is how I would write my final answer. I'm going to write in function notation. I'm going to do it in red. F inverse, colon. I need to write my domain. What's the domain? We found out the domain of the inverse is -1 to 5. So here we go. -1 to 5 maps onto the code domain, which is R, because we're taking the numbers from the real numbers. And here's my inverse function, f inverse of x is equal to x minus 3 on 2. That's your proper way of answering a question in year 12 at the end of year for a 2 marker. Why is it 2 marks? You need a domain and you need the correct function. Okay, that's all the 2 things they're looking for. Now you didn't have to actually do it this way. Now you could actually just write the domain separately, and then you could write the function separately, and that still gives you 2 marks. But I'm just telling you, as good habits, when they ask you to define the rule, define the function, write it like that. That's how you get your 2 marks easily. Yes. So if you had the function and the domain separately and you defined it, that's fine. But yeah, so I'm just running it like this because in one answer, I get both marks. And that's the expectation. So it's different in year 11 and year 10. Everything before that, we weren't pedantic about your steps. We weren't pedantic how you lay it out. This is why exercise 1A was important. You've got to learn your notations. You've got to learn the language to write it out properly. Okay? So there you go. You can watch this again, but that's essentially what you're doing. So what have I covered in these 3 steps? Domain switches with the range. So I've done the 3rd point. I've talked about the reflection, which is your first point. And the second point is it a one-to-one in order for it to exist? I drew the linear graph to see. All of that put together gave you how to solve for the inverse, write it out properly, along with the domain and range. This is technically, that's it. That's 1F. What's the hardest part? Sketching the inverse, because I still haven't sketched the inverse yet. Okay, I only sketched the function, and we're missing the inverse. That's the hardest part. But now that we've got x minus 3 on 2, that's pretty easy. We now know that the y-intercept is at negative 3 on 2, and you can solve for the x-intercept. Technically, it's just switched. Negative 3 on 2 becomes here, and then 3 becomes there. So it's likely to look like that. Okay, so that's what I mean by learning to sketch the function and then the inverse. So what's the hardest part of for 1F is when you're starting to do questions like that one. Maybe like that, because there's a domain. Okay, to be careful with the restrictions of this graph. It's not just an x squared minus 2 anymore. It is now x squared minus 2 greater than or equal to 1. That makes it a one-to-one. So now that you have a one-to-one, you can have an inverse function for it, sketching it properly with a domain and range. Okay. I want you to have a go with C. Let's go with C first. We'll do C together, but I want you to do it first, and then I'll do the solutions, and I think that should conclude our lesson for today. But that's inverse functions in total. Yep. When's our test? Today's F. We have G, which is the last exercise, and then I don't know, I thought there was only one more. There was applications. What's G? Oh, no, sorry. That'll be 2, yeah. So it will likely be next Monday, I reckon, because this week I just want to take out functions. We're going to have revision, and we're going to have GH, and our double session. So yeah, so technically it'll end up being 2 revision sheets before your in-class test for chapter 1. And we'll move on to chapter 9, but I'll go through chapter 9 faster. You would have done it last year. Let's go. I'm going to give you, what's that? It's 20 now. You got 5 minutes. Yeah, I'll give you 2 minutes to do, and I'll give myself 3 minutes to do the question so you can check. Okay? I want everything done correctly. So for C, get the domain and range correctly. I want you to sketch the function, and I know it doesn't say here, but can you also sketch the inverse? Because that ties up what exercise 1F is. Sketch the inverse. How do you sketch the inverse? You've got to find the inverse equation, have the domain, and sketch it appropriately. And that's the key. That's the difference. Find the inverse. Quadratic. So when you do the inverse, it's likely to be a square root type of graph. So you've got to visualize what the square root graph looks like, read the transformations, left, right, up, down, and sketch. Okay, so this is just a template for you. Do C. Give you 2 minutes, and I'll do the answers with you. Is that a question? Yeah. Oh, yes. do know is that F2, and what it should spit out.
So then how would you draw that graph like this?
And then at the same time, it also talks about by something like
Right here? Inverse or X2 minus 2, which means the same way that minus 2 and then put 1 into the graph.
But if the domain is from 1 to
Yeah.
yeah, so 1 to
Is that where X is 1 or is that where?
oh my god, and then F is 9 is that's what I'm talking about.
Oh wait, where X is 1. So I'm thinking about X is 1 and it looks like X is right now. Yeah. Because like, if X is 1, then and get the Y. There's no Y except that. Yeah, it's that one. There's no Y. There's no Y.
But then, if how do we find the endpoint?
Because it says X is 1.
Yeah, but this one would be 1
yes.
Let me just figure out when. Oh yeah. Okay, that's it.
It's like this, it starts right under 1. That's my first one. There is an endpoint.
How's there an endpoint? Yeah, obviously.
No, I'm not talking like that.
Does that mean that
Well, it doesn't even exist, does it?
No, it's a 1 to 1. Draw it out.
I know, but when you do like this, then it's sort of straight up. I'm not
Something wrong with your damn cards. What do you use?
That card does actually sound like just like excellent.
I'm gonna do this program at home.
This is trying.
Yes.
Function. Let me see. Does it even work out?
Functions for